Okay, welcome. It is the top of the hour. This is your host, Dave from Zook and Vitech. We're going to continue to let folks gather here, and we'll get started in about 2 minutes. Well, hello, everyone, and thank you for joining us today. My name is David Gamble, and I'll be your host for today's webinar. Today's topic is Mastering Uncertainty, Elevating Project Success with Model-Based Threat Management Strategies. We seem to have a nice group of participants here today, so we're hitting upon another topic of interest. With us today, we have another exceptional subject matter expert. Many of you may recognize him. But before we meet our presenter, there are a couple of housekeeping items that I need to cover. First, we are recording this webinar for your reference later. Second, you will see the control panel typically on the right side of your screen. By default, you are muted, but we encourage you to ask questions. Please submit your questions in the questions window, and we will answer them during the presentation or during the Q&A session at the end. And finally, we're going to be asking 3 poll questions during this webinar, and we will share the results so you can see how others have responded. Watch for the pop-up window when it's time for the polls. So today we are joined by Brian Selvey. Brian is Zook and Vitech's Chief Innovation Officer. He is responsible for managing the product strategy department and the company's product portfolio roadmap. Brian has 20 plus years of experience in the aerospace, optical observatory, and defense system domains. Brian has held senior systems engineering management and leadership roles at the United States' extremely large telescope program, Worldview Enterprises, and the Large Synoptic Survey Telescope. He has served as the risk manager at several of these companies and has implemented risk management processes on new programs and at the enterprise level. He has also worked at SpaceX in their early days, where he was responsible for the Falcon 1 ground support systems. Brian has diverse experience with several MBSE tools and modeling methodologies. Welcome, Brian. Thank you for being here today. So let's go ahead and get started, first with a look at the agenda, and then moving into our first poll question. So our agenda for this webinar, we're going to start out by showing you a couple historical examples. Then we're going to show you risk management and how it relates to the product development lifecycle. We will try to describe the 3 pillars of threat management and go into a little detail there. Then we'll talk about model-based threat management capabilities in both SysML and CSDL. And then finally, we'll talk about threat management in a digital engineering ecosystem. So that'll lead us right into our first poll question. All right, poll question number 1. Do you currently conduct any of the pillars of threat management in your organization? So try to think about what those pillars could be and let us know if you believe that your organization conducts any of these. Okay, so approximately 60% of you voted. And as you can see from the answers, the three pillars are risk management, opportunity management, and threat management. And it looks like 42% are only engaged in risk management, and slightly less, 35%, do all three. And interestingly enough, about 12% do not follow any formal processes. Does that spark anything in your mind, Brian, about what you would expect?
Yeah, so it pretty much follows what I was expecting. Obviously, risk management is the discipline with the most history and has been followed the longest. So having the majority there is uh, is not surprising. The flip side of the coin, which we'll talk about, opportunity management is up and coming and becoming more prevalent. So seeing some responses there also is good to see. The fact that we do have some that are doing more comprehensive threat management is really interesting, and I'm excited to hear more about what our participants are doing there as well. So nice spread, but yeah, it kind of follows what I was expecting.
That is awesome. More than a third are doing all three pillars. Okay, Brian, I'm going to hand it over to you.
Great. Well, thank you, Dave. Thanks for the introduction, and thanks for everybody joining us today. Yeah, and so we'll go ahead and get it started. We'll start with some historical examples, and of course, it's always nice to look a little bit in the rearview mirror to look and see what has happened historically to give us some context for where we are today, and maybe what will be some best practices for what the future can hold. So, excuse me, one of my favorite examples. We're going to go way back in time. We're not going to go back to the early 2000s or 1980s. We're going to go back a couple hundred years. So the Vasa ship, some of you may know this story, but I found it incredibly interesting. The more I learned about it, I thought this is obviously, as a systems engineer, I thought this is an example of systems engineering gone wrong. Of course, they didn't have systems engineering back in the 1600s, but we can put it in that context. So the context here is in Sweden in the early 1600s, they were an incredibly huge, powerful navy. They're one of the biggest powers in all of Europe. And they were building some of the most state of the art ships anywhere in the world at the time. The Vasa was one of their newest, biggest, and best ships that was commissioned. Unfortunately, it sank within 20 minutes of setting sail on its maiden voyage on August 10th, 1628. So I really love this quote, and it talks about the ship survived the first blast of wind that it encountered, but the second gust did it in. So what happened? They spent an incredible amount of effort, and its operational life was literally 20 minutes. So let's take a quick look. So the Swedish king, Gustav Adolphus, he built Sweden, as I said, into one of the most feared powers in all of Europe. He signed a contract with one of the world-renowned shipbuilding experts, Henrik Hybertson, to build 4 new ships. And back then, there weren't engineering drawings or anything like we have today. It was all through an apprentice program to become a master shipbuilder. And really what they did was at some point you gained enough knowledge and you understood almost inherently, it was an instinct, what the dimensional ratios had to be. So if a ship was going to be certain length, it had to be a certain width, certain height, and there's all this ratio sort of work. And they would simply lay out a few basic dimensions, and they would fill in the details as they went. So unfortunately, he falls ill, and he ultimately dies early on in the project. And he has a very young apprentice, Hein Jacobson. So he was thrown into the hot seat at a very young age, did not have a lot of experience, and he was thrown. So there was a basic design, but he was thrown into the hot seat and had to basically act as like the chief systems engineer, systems architect going forward. Now, unfortunately, what happened was, in modern day terms, we would call it a change order. So the king, who is sort of like the customer and the program manager, he comes in and says, "All right, I want to double the number of cannons, these 24-pound guns on the ship." They had a good supplier; these things were built perfectly, tested. But he goes, "I want to have twice as many." So typically, what would be done at this point, a master shipbuilder would cut the ship down the middle, lengthwise, widen it, to distribute the load further, and then put it back together. Well, Hein Jacobson did not have that experience, and he simply, if you look at the picture on the bottom right, he said, well, we've got another deck, let's just put the second set of guns on the higher deck. That obviously had the effect of raising the center of gravity, making the ship more unstable. They did conduct a test. They took 30 men and had them run back and forth on top of the deck in dry dock, and it shook and rolled so violently that they halted the test, which should have been an indicator that there was an issue. But instead of going back and addressing the problem, the king goes, we're under schedule pressure. We've got to get this ship out. So they launched it, and we all know what happened. So let's look at this from a risk perspective. There's a personnel risk, right? They did not have a backup plan for when the master shipwright fell ill. So that was a personnel risk. There is a customer risk. They changed the spec, right? They changed a design detail. So that resulted in a requirement risk. They did try to mitigate it with a test, but they decided to ignore the results of their mitigation activity because of that schedule risk, which became king and ultimately was realized and doomed them. So you can look at this problem from a number of perspectives, but I think it's an interesting systems engineering problem, and definitely has really appropriate tie-ins to risk and opportunity and threat management. Well, their failure is our opportunity. So if you ever go to Stockholm, Sweden, the ship, because it sank and it was sitting in the bottom of that harbor for hundreds of years, they were able to raise it and put it back together. And now it is one of the most amazing museums I've ever seen. So if you go to Stockholm, I would definitely recommend you go. You can see some pictures of it on the right. It is one of the most complete models of a real ship from that era of anywhere in the world. So their failure is our opportunity. We can see it today. Modern man can see it, and we can learn from it. I'm going to jump through a couple other examples just really quick. A more modern one, I think we probably all know about the James Webb Space Telescope. There are a lot of technical challenges. The fact that you can't replicate the space environment on Earth, leads to some technical risks. There were a lot of moving parts. This thing had to be tightly bundled for launch and had to unfurl perfectly for the first time in orbit. So they did a lot of testing, and all those technical risks were successfully mitigated. I think, if you watch the news, you're going to see all these interesting discoveries that have been coming out, and it's been a wonderful success. So they did a really good job of risk management at the expense of significant cost and schedule growth. If we look at the other side of the coin, opportunity, I think Lego is a really interesting example. It's a company that's been around a long time, since the early 1930s. They were the market, an iconic brand for most of their history, all the way up until the early 1980s. They were innovative. They put out toys that kids loved. But then in the 1990s, they started to lose that market position. Innovation never lasts forever. And in the 1990s, there were other competing experiences that were popping up. There were the digital play experiences with Sony and Nintendo. Lego's brick patents expired, and their competitors relocated production to low-cost centers like China. So they were getting hit from all angles. Innovation is actually opportunity management, right? You come up with a portfolio of different options that you want to try, knowing that many of them will fail, but you are looking for strategic ways to exploit possible future events to your advantage. And they hit the nail on the head with a few of them. They introduced minifigures. That wasn't part of Lego early on. That was an innovation that came much later. And they started to collaborate with other popular brands, right? So you can get a Lego set that is branded as Minecraft, or I love some of the Lego space sets. There's replicas of the International Space Station, etc. So they've done a really good job of branching out and creating experiences for people. So I think that's a really interesting example of opportunity management. Innovation is opportunity management. They're not really any different, and they really hit it on the head. So, I also like to look at interesting historical quotes. So probably most of you have heard this one from Winston Churchill: "Those who plan do better than those who do not plan, even should they rarely stick to that plan." That's the whole point, right? That we have to identify options of what we could do if the plan fails, or approaches to proactively reduce the probability of deviating from the plan. It's risk and opportunity management. But the point is to be audible ready. It's to have in advance thought about how are we going to react if those future events, both negative or positive, occur, so that we exploit them to our benefit. Donald Rumsfeld, another interesting quote, our former two-time Secretary of Defense here in the U.S. He goes, "There are known knowns. Those are the things that we know that we know. There are known unknowns." That's to say that there are things that we don't know, but there are also unknown unknowns. Those are things we don't know we don't know. What we're talking about with threat management is really the second, the known unknowns. It's being proactive about identifying what we don't know, or where, based on experience, the things that could go wrong in the future, because we have imperfect knowledge, and collectively getting the insights of the whole entire team and all stakeholders to identify those and be proactive about how we would respond to them if they occur. That's really what we're talking about. All right, so let's go in and talk a little bit about how, we'll start with risk management, since that's the pillar that everybody seems to be most familiar with, and talk about how that is really woven into the product development lifecycle. So I'll look at it from a couple different perspectives. The first is the international standard that most of us in systems engineering are familiar with. It's ISO 15288, and it's divided into these 4 pillars. I think we're probably all very familiar with the technical processes. That's where we spend a lot of our time, and we gain expertise and insight, and get a lot of depth. There's also all these management processes in the middle, where a project cannot be successful if we do not put in these management processes on top of the technical. And of course, you're going to see front and center, right in the middle, there's risk management, right? So it's identified as a critical piece of systems engineering by the ISO, IEC, IEEE international standard. Let's take another couple looks. If we go look at NASA, they talk about what a systems engineer does, and there's some overlap between PP&C, stands for project planning and controls. And this is just a different variant of the ISO standard, but again, you can see risk management. It's systems engineers. They explicitly identify are responsible for managing the technical risks. Project planning and control, they say, has overall responsibility for risk management, but it is shared. It's common. The Defense Acquisition University here in the United States also explicitly states that systems engineering has to plays a critical role in risk management. And they talk about the role of the systems engineer versus the program manager. The systems engineer is primarily responsible for those technical risks, issues, and opportunities. And they talk about all 3 pillars of threat management right there. But they also say that you can't look at those in isolation. You have to assess and describe their cost and schedule implications. So we're talking about the tie-ins, the relationships to the parts of risk management that traditionally the program manager or the program management office is more responsible for. So they're explicitly saying you can't do this in a vacuum. You can't isolate it to the program management office or the systems engineering department. It has to be integrated. The diagram on the right is a risk breakdown structure, and this is from the National Science Foundation. They've done a lot of incredible research and have put in place some really remarkable standards, in my opinion, about how to do this in a holistic, systematic way. But this is one way that they talk about. If you create a breakdown structure of your risks, it helps you brainstorm where the team can think about, do we have risks in each of these focus areas? And of course, the systems engineering team, as identified here, are going to be focused more on the technical, the requirements, technology, performance, reliability, quality, etc. But again, not in isolation. So even despite everything I said, I know that there are some skeptics out there that say, risk management, it still sounds like a program management thing. My company doesn't make me do it. in systems engineering. Why should I care? It's inherent. So in my opinion, you can't ignore it. There's always you're always going to have to make decisions under conditions of uncertainty. We know that risk is inherent in the development of any complex system. Nobody's going to understand the entirety of how that system is going to be designed and built. And there's a lot of things that are outside of our control. Those programmatic risks, right? Our customers can affect our funding. Subcontractors can delay things and send things in late. We do not have control over all the conditions to build our product. And so there is always inherent risk and opportunities. We saw that the technical risk management by a number of different international organizations has said that's the responsibility of systems engineering. And we talked about it's not standalone. You can see on the diagram on the right, a risk can have impacts or factors in multiple dimensions. And I think the biggest thing from an object-oriented, model-based systems engineering, system architecting perspective is those risks don't stand alone in a vacuum. They're generated by something. It could be it could be a requirement as an example, and they can impact other things. And understanding the where and why is critical to that good decision making. In a graph model, you can see both the causes and the potential effects, and you can make better decisions if you have all those connections. So let's go ahead and then we talked a lot about risk management. We've hinted at threat management. Well, let's formally define that now. So threat management is a broader, higher level term that is now being used to cover 3 subcategories of uncertainty management. And some are talking about events that have occurred in the past, and some are talking about events that could possibly occur in the future. So if we think about, typically we think about the future-looking things, and we're familiar with risk management, right? Those are all these possible future events that could have a negative consequence. Opportunity management is the flip side, possible future events that could have a positive consequence. But if we look in the rearview mirror at the past, issue management, or when we get to Vitech's Comprehensive Systems Design Language, or CSDL, what we will call a concern, those are events that have occurred, they have realized. So they used, at one point in the time, in the past, they were a risk, but they've occurred, and they are impacting the project in some way. So rather than ignoring them and leaving it to chance, issue management is about continuously managing the impacts that those events in the past are having on the now and can have on in the future. So the diagram on the right is from the Defense Acquisition University, and they flowchart this out right into these 3 pillars. I wanted to try to think about it in a different way, like in terms of time, like I said. So this is a different way to potentially visualize it. We've got a project baseline. The x-axis is time. The y-axis is you can put in whatever your variable is, but variances from the baseline plan. It could be technical performance, it could be risk, it could be whatever you want, it doesn't matter. But we've got a project baseline, and as we all know, actuals will always deviate from that. We could be better, we could be worse at any point in time. So that's our project actuals. The difference is our variance. That's all typical project management stuff. No surprises there. But where we're talking how this feeds into threat management, all those deviations have impacts that are forward-looking into the now, that are still impacting us. If a subsystem was delivered late 3 months ago, it still impacts us today, right? It could be impacting our ability to assemble the system, integrate it, test it. It has impacts now and into the future. That's about issue management. How are we going to react to those events in the past proactively so that we either minimize the detrimental effects or optimize or increase the potential benefits? If we look forward, I'm using this concept called the cone of uncertainty for looking forward. It was adapted from the link that you can see at the bottom. It's used a lot in agile development. So they talk about the cone of uncertainty, all the possible future things that could happen, and then whittling it down to plausible, possible, projected. But you can see they even acknowledge that there might be a preferable that is different than the project baseline. So if we want to put this in those terms, any deviation from the project baseline that has a negative possible impact, those are risks, right? Any deviation that is in the direction of a more preferable path based on better future knowledge, those are opportunities. So this is just a different way. When I was trying to think about how would we visualize this, this is a different way of thinking about these three different aspects. So how would we start to implement this in terms of a process? I think probably, there's many different ways to do it. There's qualitative and quantitative risk and opportunity assessments. This is the qualitative one where you bin these things into categories. And we're probably all very familiar with the 5x5 risk cube, which you're kind of seeing on the right of the severity and occurrence thing. You could essentially try to fold that piece of that matrix over that y-axis, and you get a resulting image that's just the opposite for opportunities, and that's probably pretty straightforward. For risk analysis, probably most people are pretty familiar with mitigation activities. So we talk about handling approaches. That's a bit more broad. On the risk side, we typically think about what can we do to mitigate it. What activities can we add to the schedule, add to the project plan to either minimize the probability of occurrence or the severity of the impact to reduce those. We could also transfer it to somebody else, avoid it. But again, if you mirror the image, there are corresponding things that you could do on the opportunity side, where we instead of wanting to get to on the risk side, we want to get to the bottom left. On the opportunity side, we want to get to the upper left, right? We want to have the things that have huge impacts and are very probable. So we want to enhance the probability or serendipity or exploit them. So you can implement this in a number of tools this way now. So that leads us to our next poll question. So back to you, David.
All right, good stuff. That is leading us into poll question number 2, and that is, where do you think you can get the best value from implementing risk and or threat management at the project program level, at the portfolio level, at the enterprise level, or really you should implement threat management in all aspects of decision making, and that is to include life outside of work. And we're starting to see the results trickle in, and in less than a minute, we will discuss those results. Okay, let's have a look at this now. Well, there seemed to be a ringer in there that people identified. About 3/4 of the voters said that you should implement threat management in all aspects of decision making, including personal life. Brian, obviously that comes as no surprise. I mean, when you formalize a process, sometimes you kind of lose sense of what that process is about, but really it's just formalizing a better way to do things anytime you're facing a problem, right?
Yeah, absolutely. We've got a lot of systems thinkers joining us in the webinar today because they're obviously thinking very broadly, and the tone is going out here, right? It's more myopic if we're just going to deal it at the program or project level and expanding out. And yeah, we all do this, whether we realize it or not in our personal lives. Whether, should I buy that new car or not? What's the impact going to be to my finances? Should I go on a vacation this year? Should I, whatever it is, we inherently do this. There are all these possible future events, and we're thinking about what are the impacts on me, my family, my circle, my friends. So I'm a little surprised it's that high, but I'm actually very happy to see that we're all thinking about it more broadly, which is great.
Yeah, no, and it's not often that you see a 0 in there, but it is what it is. And 3/4 said all aspects of life. All right, back to you, Brian.
Great. Yeah, and I guess one other thing I'd say there is it's hard to implement like at the enterprise level because you've got to think about across the portfolio. There's trades of if I reallocate funding or staff, there are going to be a lot of just tangled interconnections as to what those impacts could be at the enterprise level. So that's very challenging. I think that's an interesting application going forward. I know there are a number of companies that do that, and it's not trivial to do, but I think that's an interesting opportunity for expansion in the future. All right, so moving right into it, let's go ahead and dive into model-based threat management capabilities in our systems engineering languages as they stand today. So I'll talk a bit about SysML and Vitec's Comprehensive Systems Design Language, or CSDL. So let's start with SysML. The version that is being used today by most people is a version of SysML version 1 or V1. And for the most part, risk and opportunity management, threat management is not really included in the language. Some of the classes, the elements, have risk attributes, but they're attributes. Risk is not a first-class concept. You can't have a risk as a defined thing in your model inherently in SysML v1 out of the box. Opportunity management is ignored. But what this has resulted in is some organizations do create their own custom extensions to extend the language. SysML is extensible to be able to implement this stuff. So below you can see an example. This is something I did from a number of years ago where I extended some base concepts so I could have risk and opportunities in the model. SysML v2, that there's a lot of work being done on that. Tool vendors are working on their implementations right now. They are taking the same paradigm. Risk, the meta model for SysML v2, which is called kernel, does have some attributes that can be inherited by all model elements, but they're attributes again. You can see the ones listed here. It's not a first class concept again. And opportunity management is again ignored. There's an extended language that is domain specific called RAML, and it has risk in the name, risk analysis and assessment modeling language. I think that might be something closer to what we're talking about here, but it's really, it's method based. So it's failure modes and effects analysis, systems, theoretical process analysis, etc. It's more on the as designed, as built sort of part of your system. It's not geared towards risk management as defined today. So there are workarounds, right? You can create extensions, but it's not really captured like the ISO and NASA and DAU processes say it should be. CSDL, if you've followed Vitec for a while, you've probably heard it called the meta model or the schema. It is now a formal language. It's got comprehensive systems design language. It's the natural language that Genesis and Vitec products are built upon. And it's a little bit different. Risk is a first class concept. You can have a risk as an independent entity in your model, and it can have multiple causes. It can be with relationships related to multiple causes and impact or result in changes to multiple other entities downstream. It's object oriented. It's an ERA concept, entity relationship attribute concept. It is an entity. Mitigation activity is also a first class concept. You can have, because we have a whole program management facility, so you can have these mitigation activities that you associate with these risks to say, here's my strategy for trying to burn them down. And we do have concern. That is what I was calling issue in the threat management lingo, also a first class concept. We are now working to extend that. I don't expect you to see that or be able to read this chart, but my point here is we are working to extend our language so that opportunity management is also included. So opportunity will also be a first-class concept coming out in our next major release of Genesis. We have a failure modes and effects schema available today. We're making 2 major updates to that as well for 2 different domains. And this will all be coming out. And you can see there's a web of available relationships to interweave these concepts so that risk and opportunity management, you can do much more on the specification side, to how we want the system to be designed, and the realization space, you're as designed, as built side with FMEA and fault tree analysis, etc. There's going to be this interwoven web of capabilities. I know I need to speed up here a little bit, so we're going to go through these a little bit quicker. I just wanted to show a couple examples of what you can do today if you want to extend a systems language to encapsulate threat management. So this is an example that I did a number of years ago in SysML with a custom extension. As I said, this is a simple example with modeling a car. Here you can see the powertrain, and I've got a couple different risks that I've identified. For the tire, I've got a risk and an opportunity, both associated with it. The traction may be inadequate to meet the stopping distance requirements. You can see that's related to the tire, which is a part, and it's related to its performance requirement. On the opposite side of the coin, there's an opportunity. If from a performance perspective we exceed the requirement, then that opens some other interesting things that the car could possibly do, right? So in this implementation, they're both tied to the block, but what I don't have here is something to relate the risk to the opportunity to show that they are paired, which we will be doing with CSDL. I have a program management risk that's tied to the powertrain subsystem as a whole. That is a programmatic risk about funding. If the corporate funding for these upgrades gets cut or is less than anticipated, then they're going to have to descope features. And we talked about risks becoming realized and becoming issues. I can also identify the exact point in time when that would happen. What is the trigger that would allow us to realize whether or not it happened or not? So I have a test sequence here of how we're going to test our subsystem. When we execute this test, we're going to get the knowledge to see if the risk or opportunity realized. I can see the exact event, the point in time in which we will either be able to retire the risk, realize the opportunity, or if one of them occurs, you flip it to an issue. Can do the exact same thing in CSDL, although I didn't have to create a schema extension. It's simply natively part of the language, so I didn't have to change anything. But you can see I have the same thing modeled with the powertrain and the technical risk, the technical opportunity, and the programmatic risk. Here you can see all the attributes that are included. We can do quantitative or qualitative risk analysis. I don't have time to talk about that topic today, but you could do both if you so wish. So we now are into our last poll question.
All right, we have reached our final poll question, and that is question 3. Is your risk or threat management process tied into your program management and systems engineering processes? Well, we conduct ad hoc risk threat management. Our risk threat management process is formal but standalone. It is integrated with program management, cost and schedule, or it is integrated into our broader systems engineering processes. All right, well, so these answers kind of built on one another, and it looks like they're kind of clustered to the edges. Either conducting ad hoc, which isn't terribly surprising, Brian, and another large swath have it integrated into their broader systems engineering processes. Any surprises there?
I guess not. There's a wide variety of responses. The one that I think is interesting is that it's not very highly coupled or integrated with program management, cost and the schedule. And I think that's one of the biggest opportunities, especially when we start to talk about once we've identified these technical risks, to make those mitigation activities real. If we're going to try to mitigate them in some formal way, those are activities that really need to be in your program schedule. They need to be funded, baselined. We have to have resources allocated to be able to conduct those, or else it's just paperwork, right? It's fake. So I think that's an interesting opportunity still. I'm sure that it's actually probably done at a higher rate than that, but probably manually. But there are opportunities so that that's more highly coupled and integrated going forward. So interesting, but not surprising.
All right. Well, we have a little less than 10 minutes before we open it up for Q&A. Bring it on home, Brian.
All right. Well, we've got one last section here before we close. And I know it's probably a burning question that somebody's going to ask. So maybe we can talk about it proactively here from a risk management perspective. I assume somebody's going to ask about how to do this in a digital engineering ecosystem. And my mitigation was to just put it in the presentation. So let's talk about that, because a digital engineering ecosystem, that's all the rage. That's where our industry is headed. So this is just a graphic that I use in a lot of my presentations to sort of introduce the topic. I'm sure many of you that talk about digital thread are very experienced in this, but for those that need an introduction, what we're talking about is, historically, we've had a number of very good application-specific design tools, and they all were typically standalone or had some way of exporting and importing information or creating manual reports so that a human could understand the information from it. As we move towards a digital engineering ecosystem, the intent is to connect those tools so the right people at the right time get the right information so they can make better decisions. And there are a number of different ways that you could architect this and design it. There could be point-to-point adapters and connectors, or another approach is these digital engineering brokers, or digital thread tools that act as sort of like digital engineering middleware. They deal with all the connections for you. But regardless of the architecture, my point here is just to introduce that this is the way that the world is heading. We have to make sure that risk management, threat management is now something that gets incorporated into this environment, because depending on your organization, this is going to look different. This is going to be, tailored to the needs of your organization. You may have a project scheduling and management program that also facilitates capturing risks and opportunities. You may have a standalone risk management tool. That could be a application-specific third-party tool, something you've developed in-house. It could be an Excel spreadsheet. I've done it a number of different ways, but you could have a risk database, opportunity database. But siloing that information doesn't bring in and get the collective knowledge of all the participants and stakeholders, right? So the intent is to move more towards something like this. And then the obvious question is, well, wait, where does risk and threat management fit into all of this, especially when there's different ways you could architect this and there could be different sources of truth. So I think the answer from my perspective is there's no right answer. It depends on the needs of the enterprise and the company and the customers. If your company is organized in such a way from your org chart perspective and a roles and responsibilities perspective where you have a project management office, a PMO that has been delegated the responsibility and authority for risk management, they're going to own it. I've seen other organizations that have separate risk management groups, enterprise risk management, and then potentially even within a program or a project, there's a risk management function. I've been in organizations where the project management office said, we don't have the expertise. We want to delegate that to systems engineering. So there's a lot of different ways that it could be done. The key point, though, is to identify where is the authoritative source of truth for that information. Is it going to be in a standalone risk tool or a risk spreadsheet? You could natively manage risks if you so wished in an MBSE tool with a SysML extension, or in Genesis with the built-in capabilities of CSDL. Or, like I said, it could be in a program management tool. In a digital engineering ecosystem, though, we have a collective set of stakeholders, all that are going to have different perspectives. They're going to have better knowledge in their domain about where there could be risks and opportunities. So as you build this digital engineering ecosystem, the important part is to decide where the authoritative source of truth is, where is that information, the master copy, going to live, and who else needs access to that, either as a window into that database where they can access it, or federating the appropriate information, subset or whole, into the other tools so that if that's the place that they typically work, they have access to and can see that information. And ideally, if we start to talk about domain-specific tools and detailed design tools, if they have access to a place where they can capture updates to existing risks and opportunities, status updates, or identify potential new ones, if they're able to do that in the tool that they use most often, all the better. They're probably more likely to engage in this as a process. So many different ways you could architect it. The point being is you have to understand the constraints and the goals of your organization. But the key is to make sure you understand who all the stakeholders are, what data they need, on what cadence they need the data, how you're going to transfer that data or make it accessible, and when you need to make changes or updates, how that is going to be managed. Especially if you start to federate the data, you have to have a digital engineering ecosystem, configuration management, change management approach. But just to wrap up, that kind of concludes my technical content. But to wrap up, few key takeaways. You cannot avoid uncertainty. It's inherent to any engineering project. We can leave it to chance, which I think, based on the poll results, we're seeing most people are. And if you showed up for this webinar, you obviously have an interest in it. Where most people are saying, don't leave it to chance. But we could take the approach to strategically manage that. And it's not just all the negative stuff. We need to expand our horizon and think more about the opportunities. Entrepreneurs do it all the time. That's what innovation is. And that's how we can make our products better, if we start to look for opportunities in an active capacity. Another key point that I want to make is, in my mind, risks, opportunities, and issues are first-class concepts. They're not attributes. They're not an attribute of something else. They are events. They're abstract, but they are things, and they can have multiple causes and multiple effects. You can't make that work if they're just attributes. So I would encourage everybody to think about that. A risk management tool creates risks and opportunities as independent entities. And as you saw, CSDL, the Comprehensive Systems Design Language, we natively include those concepts. Of course, everybody's going to have their own needs. Tailor as you need it, right? You may have, in your industry, you may have standards that you have to comply with, and you may have to create additional attributes or tailor. Please do so. But the intent is start from a foundation that is solid, a key foundation. And of course, you got to assess those interoperability and reuse aspects of it, especially when you start to go to a digital engineering ecosystem, or as you start to build processes within your company and methodologies, and you want to start to deploy them on new projects, et cetera. You're going to have to think about that interoperability. And I think this domain is really going through some exciting evolutions. We've talked about, in the distant past, all the way back to the VASA, was ignored. And then we got to the point of doing formal risk management. Now we're doing risk and opportunity management. The next evolution is to make this object-oriented and model-based, in my opinion, and incorporate it into your digital engineering ecosystem, with the intent that people make better decisions if you get the right information to the right people at the right time. Because ultimately, all this is all about is we have to make better decisions under conditions of uncertainty. And that's all I have. So I'll hand it back to you, Dave.
All right, thank you very much. Good stuff, good stuff. So I think we have time for a few live questions. We are gathering them here for you, Brian. Oh, wow, we're going to start you out with a softball here. Brian, how do you deal with people self-censoring risks that they are aware of out of fear for retaliation?
Yeah, well, I don't think that's a softball. That's a hard problem to solve, in my opinion. But thanks for that, Dave. This is a big one because there is that fear of retaliation. I've worked in enough projects in different domains, and I know that there are people that it's inherent to people. Am I going to get in trouble if I let them know that there's a problem, right? So it's the only way you can do this is to instill, in my opinion, and I think we've been fairly successful a few places I work, is you have to instill, it's a corporate culture, it's a project culture of psychological safety. You have to make it so that people inherently feel like they're trusted and they're safe to speak their minds. That doesn't come overnight. It doesn't come from management telling them to, that it's okay. It's from leadership and management walking the walk, not just talking the talk. So the way that we had to do it when I was at the Large Synoptic Survey Telescope is we actually changed our process a little bit. One, we said that this is all for the benefit of the project. And again, it took time. Nobody's over time, as somebody would step up, they would see that there wasn't any retribution. But the other thing that we did to try to, we did a couple things to try to get over that hump. One, as the risk manager, I would meet with small groups and all the subsystems so that they weren't part of this large group. I would sit with them in a smaller group, ask them questions about how things are going, and having those smaller meetings that made them more personable, I think helped. The other thing we did from a process perspective is we created like a proposed risk category. So we said, you can propose something. It's not going to go into the live database. It's not going to go to it's not going to go to external levels of management outside the project. It's certainly not going to go to our customer, but you can put it in there. It's a holding cell, and so you can put it in there. We'll have an internal discussion, and once we review it and evaluate it and work out the kinks, then we're going to come together as a group and we're going to elevate it to a formal risk. That step alone helped quite a lot because people felt like, oh, it's not formal yet. I can just sort of, I don't have to think about, I don't have to understand everything. It's a holding pattern thing. So that helped a lot.
Yeah, there's plenty of historical examples where disaster occurs when people are afraid to speak up. All right, probably have time for one or two more questions here. Here's another. When creating a central model that helps deliver the needed data to the right people, do you know of any rules that of an engine for that data to reach the right people? And also, how do you avoid delivering too much or irrelevant information and creating noise in the minds of the decision makers?
Oh, that's an interesting concept and something that we here at Bitech are thinking a lot about how to make this work in the future. And I think about it, I keep using this term like cone, but I think about it as a cone. At one end, it's all of the information, in this case, your domain of risk and opportunity and issue management. And at the other end is an individual, potentially in a different domain with a specific viewpoint. They have a specific domain knowledge and they need a subset. Today, I'm not aware of any really great way of whittling it down, but that's something we are actively trying to work on. And it's thinking about, it's not going to be pressing an easy button or a magic button, but I think it's going to be going through a level of discrete steps so that you identify, it's sort of an extended view and viewpoint concept for those that are familiar with it. You got to start with the person consuming the data. What is the language that they understand? A lot of them aren't going to understand jargon of formal risk and opportunity management or systems engineering, but what do they understand? And what do they do and what do they need? So you got to look at their roles and responsibilities. Starting from there, you can work backwards and figure out how do you whittle down the set. So based on that, you can initially decide what subset of the data might be appropriate. And there's probably not an easy button for that, but at least it gives you the context. And then you have to start filtering out what they don't need and mapping it or translating it into the language that they understand. Because I think that's one of the biggest problems in digital engineering is today still is there's a lot of domain specific jargon. It's just like natural languages around the world. If we all come together in the same room and there's not translation apps or translators, we're not going to communicate. It's no different with program and engineering data. We have to start creating, that's where we can do a better job and the tools can do a better job of helping translate concepts and terminology from one domain to another. So I don't think there's an easy button, but it's whittling it down. What's the viewpoint? What's the subset of the data that domain needs? And then how do we filter it so that they understand it?
All right, excellent. So a little bit of a speed round here. In one sentence or less, if you can, Brian, how early on in the product development life cycle should you start putting emphasis on risk and threat management?
Well, yeah, it's no different than the value proposition of systems engineering. The more you do earlier on, the better the results turn out. It's no different for risk management. Early on, there's going to be more uncertainty, right? That's that cone of uncertainty. We will know less, but everything that we don't know is a risk or an opportunity. They may be more generic, more top level. So I can't answer it in one sentence, but it's going to be more generic, but very early on. And then it just changes and evolves as you go forward. Yeah.
Yeah, that makes sense. Okay, well, that concludes today's webinar. Thank you, Brian, for sharing all of that with us.
Definitely, you're welcome.
All right. So, just want to let you know that you can connect with Zukin and Vitek on LinkedIn to continue this conversation or any other things that you want to talk about with us. And I hope that you found this webinar very interesting and very helpful. Just a reminder that an on-demand version will be available soon for those of you who want to view it again or share it with a colleague. This event is part of Zukin's 2024 technical webinar series, so please visit our library of technical webinars on the web for more informational topics. Our next webinar will be on Wednesday, May 15th at 2 p.m. Eastern. It is entitled From Chaos to Control, Transforming Project File Management. For more information and to register, please visit Zukin's website. And also, it'll help us out a lot if you take a moment to let us know how we did. We like to make these webinars better and better as time goes on. It's a very quick, single question, and we always appreciate your feedback. All right, and I just want to thank you all again for attending, and I'd like you to have a great rest of your day.